But unfortunately, a lot of them don't. And so these are third-party servers of, for instance, CDNs serving certain JavaScript. They can be third-party tools like analytics platforms or your ads. Basically, ads are just another JavaScript distribution network. So it's a fundamentally large part of the internet that's just being fetched for somebody to go to a website, and you have very little control over that, right? And so coming to the point I said earlier, we're basically spending a lot of money at this, the perimeter around your own infrastructure. So all of your firewall vendors, it's about 20-30% of the floor here is that. And then there's another 20-30% of the floor that focuses on that, helping you write secure code, prevent that code from doing bad things on your server or on the actual developer's device. Lots of supply chain security solutions that really only understand the server or the actual developer's environment. Lots of IT tooling for internal IT and laptops and all that kind of crap. So, this part, what's happening with your application in the browser, nobody knows. That's really the problem here. And the thing is that browsers are incredibly powerful. We keep on adding more functionality to it all day, every day. Browsers are really just feature-rich environments. More and more things are also just becoming browsers. Mobile apps, progressive web apps, web views, they're really just running full browsers with the full exposure to all of the issues that browsers could have. At the same time, we're also just running browsers in places that we don't really have to run them. Fridges, Teslas, all that kind of stuff. Like, why is that a thing, right? So there's this weird curvature of more features going into browsers, more things being browsers, more things running browsers, still significantly nobody really making progress in understanding what is happening inside of them. And that is, of course, a big attack vector. And something that bad actors love is a world in which a specification and the way it is actually implemented, there's a significant gap in the middle. Because you can get very creative with that, right? I mean, at the end of the day, if a specification just allows you to do something, but the way it's implemented allows you to do a bunch more stuff that is undocumented, well, that's significant. And that is really the case with browsers, between different engines, between different versions of browsers even. And so bad actors love that. As a result, in Q1 this year, we spotted 300,000 websites with new client-side attacks on them. And I mean, 300,000 on the entire scale of the internet you think is not that much, but it's been like this since we started last year. We keep on finding new attacks that basically use the browser of the user to steal stuff. And so when I speak about stealing stuff, I'm talking about quite opportunistic attacks, things like malicious redirects, and I think all of us have been on a website that suddenly redirected you to another site. That's very common, that's a common one. But equally, rendering an iframe on top of the payment form. And you would type in your credit card information and would say, oopsies, try again. The iframe would disappear, you type it again and now it's successful. Your credit card was just stolen. That's a very common one. There's various different ways that they steal credit cards that way. They also like using browsers of people to attack other people, so performing DDoS attacks against third-party services by chucking a JavaScript in an ad network and then using the browser of an unknowing person. And that is completely unstoppable, right? Because the bad actor is using a human browser, your grandma or even yourself, from a normal IP address. There's not a single fingerprint there. So the types of attacks that you can do here, it's quite creative, and we see a whole bunch of them. In fact, it's not necessarily just attacks, it's also just weird JavaScript in general. I'll give you an example. One of our customers is a payment provider. One of the payment options that they allow is Alipay. Alipay injects a script into the website that artificially slows down the page speed when they can't handle all the payment requests they have to handle. So in your company, you then have a bunch of people whose bonus depends on performance, and they do everything that they can for then Alipay to just be like, don't have enough servers, I'm going to slow down your site. That kind of stuff we spot. It's very hard to spot those things. We spot those things. And then you can think, well, okay, but what about vulnerability scanners? Well, there's a lot of those companies. The problem with client-side attacks is that they are dynamic in nature. Every user agent can get a different script. Any user can get a different script. If I had access to a client-side script, I could literally target a single IP address in the world, or 1% of users in France after office hours, or 5% of users using an outdated browser. You could go that level of targeted. So if you got a crawler, they're obviously not actually going to see the bad code first party ever. This is one of those scripts like, if you see navigator language is mobile and the time is after, then make this malicious sub request. And it's just simple JavaScript. Like, there's nothing malicious about this per se. The malicious stuff is going to be in there, right? This is just not going to get spotted by any crawler-based solution. And so what's out there already? Has anybody here ever tried to set up content security policies? Hey, a few people. You look remarkably happy for having used CSP. It's a disaster. So what CSP is, you're basically defining in the browser in an HTTP header which third-party scripts by URL are allowed to be fetched. The problem is that they have no understanding of payload whatsoever. So I've got two boxes here. One of them has a bomb inside and the other a puppy. Tell me by the looks which one is which. That is how CSP works. So you see the problem here, right? You should under no circumstances build a security company on CSP. There are plenty security companies that are built on top of CSP. It's pretty bad, but there are solutions like that. This is an okay layer in security. It's nothing on its own, right? Then the other option is crawling a site. I already told you, it's a bad idea. With a little caveat, if you don't expect to see the malicious code yourself, but you get this malicious scripts through other means, you can still do an okay job with it. But problem is that doesn't really do it. Then there's a couple of companies, and there's actually a few of them here, that do client-side hook-based security. It's actually one of them here that I know of. The problem with this is you're literally defining mousetraps in the browser of a user. Now, what would you do if you saw a mousetrap right in front of you? Go around it, right? Well, guess what? You're making a very clean map of mousetraps because it is actively being put into the browser. The result, the bad actors, they know what not to do. And therefore, they just don't do it. There's about 100 ways you can get from A to B in the world of JavaScript. It's not particularly difficult to avoid this. In fact, you don't even have to be that level of sophisticated. Unlike operating systems, the browser fundamentally allows JavaScript to be kind of equal to each other under most circumstances. So if there's a JavaScript in a website that is trying to monitor for specific behaviors, then we put a JavaScript in there as well as, like, let's say a bad actor puts one in there. The bad actor can just say, nah, I don't like that other JavaScript, I'm going to start overriding parts of it. So you can just override the alert. So let's say an alert is triggered, you did something bad as a malicious actor, you just override where the alert is being sent to, you've just avoided this fancy 100K a year security solution. Unfortunately, that's really a number. There's people paying more than 100K a year for this kind of crap. And so it basically comes down to, I worked in this space for a while, I was at Cloudflare in the past, and I mean, I just recognized that this was a space that was being underserved and was a lot of over-promising but under-delivering, and stuff just had to be done differently. And this needed a real company that focused on it, because Akamai, Cloudflare, Imperva, they understand looking at network packets, they don't necessarily understand JavaScript engines. It's a very different thing to look at. And then, of course, dynamicness means you can't apply static analysis on it the same way as you would. And there wasn't really a company doing that. So there you go, there's cside. And so what we do, and this may sound a little drastic, but there's nuances to it. We basically put ourselves in the middle between these weird third-party services that you have no control over and your end user. This, for some people, is a tough pill to swallow, but I'll talk about that in a second. But the fundamental thing here is that thing that you have no control over whatsoever, you can now see the code. We can analyze that code. In fact, we even store that thing. If we miss an attack, we can even tell you who got the bad script. We can then improve our detection capabilities based on what we've seen. We actually have all the data there to build a pretty significant security solution out of this. Our competitors just don't, right? And so it comes to the level of, well, are you just buying threat feed intel, or are you actually trying to detect one yourself? We try to detect them ourselves, and we find a lot of them. There's more nuance to it as well. First-party JavaScript, we don't necessarily proxy those. If there are scripts you don't want us to proxy, we still analyze them other ways. There's a lot of layers in the system, but I mean, fundamentally, that weird third-party service, you now have complete control over it. In fact, we often even make them about 30% faster. The combination of those things makes for better security, better performance, better visibility for you, and now it's actually your side, including those weird third-party tools that you use. Let's talk about some attacks we see. And we'll do some questions at the end for those of you that have questions. This is a very standard one that we see quite common. Client-side injections through things like Magento and WordPress is very common. Many reasons why. Server-side vulnerabilities that allow people to inject code, as well as literally thousands of themes and plugins on the WordPress ecosystem. But yeah, this one is going after session tokens. For those of you that may not understand that part of technology yet, session tokens is where people's login credentials are really like stored in a format, right? So you log yourself in, you pass MFA, it generates a key, and it stores it in a session token. If somebody takes that session token, puts it on their laptop, it's often just gonna work. So this is a hot token that allows you to get access to a logged in environment, bypassing all of the authentication that you have done. This thing just pulls it out of it. In fact, every client-side script that is on a browser, including the ads, have the ability to access this. There's nothing stopping it. So that's, of course, a quite common one that we see. The second thing is, and this is quite a niche one, but unfortunately the most common of them all, probably, crypto websites. So let's say you're an online gambler and you like a specific gambling site and you get paid out in crypto. A lot of these gambling sites have ads on them. Those ads are not networks like Google Ads. They're secondary networks because Google Ads doesn't want to touch that. Well, people are putting malicious JavaScript on those networks and they have nothing in place to prevent those malicious scripts from running. So they just override the crypto wallet ID. So you type in your wallet ID to get money out and they're just overriding that post request when you click save. Very common, ridiculously easy. I mean, yeah, you can count the lines of code. It doesn't take that particularly like a high level of intelligence to do that. Credit card theft, a lot of different ways to do this one. Just literally stealing it out of the form is one of the more legacy approaches. The iframe method that I said where you overlay them, that's another one. Capturing the post request is a very common one. Just listening to keystrokes is the most easy of them all. Just you press a button and it gets logged. Nothing stopping that, so there you go. And then usually people also use some type of timeout for that. This is actually referring to the one that was used in the British Airways attack in 2018. Who has actually heard of the British Airways attack in 2018? Should be quite a few people, yeah. The data was being sent to baways.com at the time. Who do you think owns baways.com today after that incident? Anybody? We do. So you can go to BAWays today, it's totally safe, and it's in extreme detail explained what has happened there. The great thing is that that document is like quite factual. It's just trying to make people aware of the problem. The fact that we were able to get that domain this many years after the attack, that also says something about this problem. People just tend to forget about domains, right? And that's another common way of getting scripts into a site. Oh, this is my little niche one that I find quite funny. I did a talk on this at B-Sites in San Francisco. So this is using the iframe method. Anyway, I'm gonna just talk about the other one. The iframe method to render a page of someone else in the browser of a user. So imagine this, your grandma, you go to the website, cool, there's an ad. The ad renders a hidden iframe on the web page that you're on, and that is actually just rendering the page of some other company that it is trying to attack. And so it does 10, 15, 20, 100 of those, and it just keeps on refreshing. Using your browser, normally like a normal browser would, fully rendering the page. You'd really have to use advanced bot detection to even detect that. On a human laptop, on a normal residential IP address that was never used in an attack before. There you go. You've just, if you manage to get this onto 10,000 laptops, you can take down a pretty significant network, right? An example of last year, who here has heard of the polyfill attack? Anybody? Polyfill, 500,000 websites suddenly started redirecting to an online casino, including major ones like The Guardian, etc. Between February and June, the bad actor had that domain as well, but quote unquote, nothing happened. We were like, something happened, we just didn't notice, right? But in June, suddenly people start getting redirected. If you manage to get a script onto The Guardian, a website that hundreds of thousands of people go to every day and leave open for a couple of minutes, yeah, you can create like absolutely millions of requests a second. And that would take down like even many of these security vendors here. So there you go, that's another scary one. Oh, there we go. Apparently we've done most of the talking on that one. Just a little bit of context. I have to say this because we are a relatively young company. We started in January last year. We are backed by the best. We've got major VCs that are helping us build this company, scale it to the next level, including the Chainsmokers. Who here is a fan of the Chainsmokers? Artists. Hey, nice. They're doing a big party on Thursday in London. What a coincidence. In fact, if you really want to go, come talk to me. Then folks, for instance, like Scribble, that's OpenAI's head of products fund. Encore Capital, they do things like Launch Darkly. Anyway, people that I've worked with in the past that have been around for 20, 30 years in this space that helped me build other security companies. So here's the thing. We are a security company, unlike many here, that actually allows you to use the products just for free. You can go to our website, sign up today, add it to your website, no questions asked. If you're trying to meet your compliance requirements, well, PCI DSS added 200 new pages to the compliance requirements. If any of you has to do their PCI audit this year, either you get ready now or you're going to be surprised when the next audit happens, but there's 200 pages of new stuff for you to do. One of them is client-side security. Why? Because MasterCard, American Express, and Visa, all of them individually pointed out that the number one way that credit cards get stolen nowadays is not ATM skimmers, it's not people guessing credit card numbers or anything like that. It's client-side attacks through scripts. In fact, it's even worse. Who here has heard of tokenization in payments? Anybody? There we go. So we're moving to a world where people use Apple Pay. Great. Those tokens don't rotate immediately all the time. Most of them have like a 72-hour shelf life. It's helpful in a way that if you pull credit cards out of a database, they're probably going to be too old, right? However, client-side scripts are live, they're hot. So it basically bypasses the entire concept of tokenization and why it would be more secure, just because you can get it live out of a browser. So anyway, any of you that has to be PCI compliant, which I think many companies are anyway, do you accept credit cards online, you have to be PCI compliant, this unfortunately is becoming a problem. And will be very cost effective as well to help you with that. And so with that, I'm done talking. I know that I covered a lot, and I know that I speak quite quickly as well. So please, if there's any clarification questions or any questions at all, now is a great time. Very elegant, it takes minutes to set up. You just gotta copy paste a line of code, really. And there's no weird isolation, there's no latency. As I said, we often make these scripts faster. We just make them come through our network, which is usually optimized already. There's a couple of tricks we use there. If they're static, we serve them through a CDN. Most of these third-party scripts, they're coming from rather cost-effective CDNs to them, but usually slow CDNs. We can be faster than that. If the scripts are fully dynamic and they are not optimized, which is usually the case, they're supporting HTTP1, we bump them up to HTTP2, or even if your browser supports it, HTTP3. All of those things make for just more optimized performance of these scripts. You'd be surprised with how many of these marketing tools do not have proper optimization of any of this stuff. It's just because they're technology companies that don't necessarily understand the importance of that or have the technical knowledge to do that even. It gets quite deep quite quickly. Yeah. Does that make sense? So the thing is, even for intranets, third-party JavaScripts remain publicly accessible, right? So it doesn't impact that part at all. If you have scripts on your site that are only accessible within your network that we cannot physically get to, well then of course we shouldn't try proxy those, right? And so that's just a simple setting that we do. And that's one of the reasons why we don't do first-party JavaScript proxying by default. There's also an element of cookies and all that kind of stuff, but yeah, anyway, this product was built to work 99% of the time purely out of the box. If you have specific scripts that are not publicly accessible, we tend to avoid those by default. Yeah. All right, so that was one question. One more here in front. I would try to listen to you from here, but then nobody else can hear. It's a good question. So first things first, any company that claims to do that, manage to stop malicious JavaScript injection through extensions on browsers, they're lying. There's literally no way you can do that. There's two major issues here. So first things first, getting JavaScript into the browser through an extension is very easy. That is technically considered on device by that browser. No amount of security that you can do as the website itself can actually, with 100% certainty, get rid of anything that's coming through that extension. I'll give you an example. Content security policies, a standard framework security thing, can be overwritten without even any form of approval by any Chrome extension that you have. You can always kick out something as a Chrome extension. So there's no solution to that. There are companies that, due to your point, run a browser isolation, render the page, and then push an iframe through to the website, to the browser of the user, and then indeed, most of the extensions would break. But guess what? If you were a smart enough developer and you knew that people were using that type of technology, you would still interpret what's coming out of the iframe, right? And that comes down to the most fundamental problem here. There's a line of responsibility and security that you have to be very clear on with your customers. What is coming from you as a company and your dependencies, that is ultimately the company's responsibility. You are responsible for that. You want to make sure that that is safe. If your user has malware on their device, that is not something that you can really do anything about, right? You can run all the security solutions you want, they would still be impacted in some way or another because of that malware on that device. When you start crossing that line, things get really confusing. And this is one of those examples. On-device extensions, yes, they are injecting malicious JavaScripts. Unfortunately, they always have an upper hand over the actual page that is coming onto that browser. Then there's no real solution to that. That's the worst part about this. Who here uses WhatsApp Web for chatting with people? Lots of us? There you go. WhatsApp has a little extension that almost nobody uses that you can install in your browser that basically verifies that your WhatsApp environment, your web environment from WhatsApp, is the one that they intended you to use. And that is to prevent these types of situations. The W3C is working on making that actually into browsers so that you can somehow verify it, but even that can be overwritten by extensions. The world of browsers is disgusting, so there you go. Sorry, I went into a bit of a deep dive on that subject. So our service, basically the script itself comes from our proxy environment. Let's say our proxy goes down, then our script doesn't get served, and we also don't rewrite the scripts. The result is that it fails open, right? So our system is built to handle that. We've got a 99.99% SLA. We do a whole bunch of things to prevent that very specific scenario, but even if that happens by design, we have made it basically that it wouldn't interfere with your actual users. That's a very important thing. Most of the people that we have within the company right now have worked on distributed systems for a long time, either because they're ex-Cloudflare people or they built some types of systems like this before. We know what we're doing when it comes to building a proxy. And we're also not trying to build it on our own hardware just yet. We'll probably end up there, but just yet, currently it's on AWS. So we also tend to lean on that. If AWS goes down in a region, then you usually have much bigger problems. So there's a lot of other issues that then will come up. So we've got a number of things that we're currently doing and that we are actively building. So of course our dashboard shows the code of these third-party services and the security scope around that. What we're currently working towards is more fraud prevention, fraud detection, bot detection, AI agent detection, all that kind of stuff. The great thing is we're a script on the side, right? So like if you want us to do more, it would be a button in the dashboard for you to press and we just do that as well. The thing is that you end up in a situation where there's basically three ways to build a security company. You can either build a company off of an actual change in the industry or change in compliance. So let's say Google is suddenly requiring everybody to use HTTPS. That was a great one. GDPR was one of those. PCI DSS actually coming to a stage that they're adding more security things to the scope. That's a great way to build a security company. That's currently what we're doing. We're solving a problem that has been around for a long time that you actually have to go ahead and do a thing. It's great. You can do a better job at some other security companies and then convince them that you're better. That usually takes a very long time because it's kind of a nice to have and never change your running system. Or the third one, you could just bribe CISOs. I don't like doing that, but that's unfortunately what some security companies do. We are very much in category 1. If we go towards a world where we do fraud detection, then we go into category 2. And so I want to make sure that whatever we do there is just going to be 10x better than anybody else. So we're building that out. And of course, client-side analysis and how behavioral sites is, those are things we can analyze. It's just making sure that it's way better than anybody else. That's really what we want to do there. Yeah, makes a great question. So first of all, we try to focus purely on third-party JavaScripts, which are publicly accessible anyway. If there is any confidential information in a publicly accessible script like that, you're already in deep trouble, right? So this is a more substantial issue. We've got some detection capabilities on our side that would be able to flag things that look like sensitive information. Unfortunately, that does every now and then fire. And so people have put data in places that they really shouldn't have. We try not to collect anything that is not necessary to the scope of what you want us to do. You want us to focus purely on client-side security because of the PCI requirements? There we go. So what we do there is we basically get the script to come to us, we focus purely on a third-party script, we don't interact with things we don't have to interact with. When it comes to use case of analytical purposes, if you want that, you're going to explicitly want to get that specific feature. So there's a big separation between the things that we do there. But when it comes purely to the client-side security side of things, there is not really anything there that is private or confidential or even personally identifiable, with the exception of one thing, and that's because that's how the internet works, the IP address, right? The IP address of a user is necessary for us to serve a script. We don't necessarily store it unless you want us to. So yeah, all right. Well, thank you so much for stopping by. We've got a booth, B133 over there. There's a bunch of smart and nice people, happy to talk to you. And yeah, I mean, if there's questions that you have you want to ask me one-to-one, I'll be here. Thank you so much.